In my last video, I showed how to describe the displacement of an object using delta x and delta y, as well as delta r. What I want to do now is I want to find the magnitude of the vector. The magnitude of a vector is the vector's size without regard to direction. And graphically, that is represented by the length of the vector. So if we know a vector's horizontal and vertical components, then the vector's magnitude could be easily found with the distance formula shown here. Now, if we know a vector's horizontal and vertical components, then the vector's magnitude could be easily found with the distance formula. We're going to use this form of it. The two lines around the vector mean find the magnitude or length of the vector. And Vx is going to be the horizontal component of the vector, whereas Vy is the vertical component of the vector. And so that's Vy. If we write the Pythagorean theorem here, that the magnitude of V squared, so the square of the vector's magnitude is equal to the sum of these squares here. If we were to solve, we would square root both sides. And regardless of whether Vx is positive or negative, it doesn't matter. Once we square it, it's going to become positive anyway. And we have this formula for the magnitude of a vector. So I'm going to use that formula now to find the magnitude. I want to find the magnitude of the ladybug's displacement vector, which I had determined in my previous video was negative 5i plus 4j. So let's go ahead and find now the magnitude of the displacement. The formula for it here is going to be the square root of the sum of the squares of these lengths here. So we're going to have negative 5 squared plus 4 squared. That'll be 25 plus 16, which is the square root of 41. Which is approximately 6.4. I'll use the same number of sig figs that we were given here in the original numbers. Okay, so that looks reasonable, you know, if the horizontal component is a 5 and the vertical component is a 4, then it's reasonable that this length here could be 6.4, yeah. All right, so delta r, notice that this could be written as delta x squared plus delta y squared, which was the square root of negative 5 squared plus 4 squared, radical 41, 6.4. Okay, now, can you find the distance that the ladybug had actually traveled? Why or why not? All right, so in the picture we see a displacement for the ladybug. So she starts off here. Okay, she ends up here. But they never actually said how she got there. She might have taken the diagonal path, or she might have taken one of these paths that are aligned with the x and y directions. She might have taken the lower path. She might have taken the upper path. Or maybe she didn't take any of those paths at all. Maybe she took a path that looks like this and then arrived at her final destination. We don't know because all we know is the displacement. The displacement's based on the initial and final positions. It doesn't tell you what happened in between. So for that question, I'll put no. We only know the initial and final positions.